Coding agents can write scripts and change project files, but Unity development involves more than editing code. Unity still needs to import those changes, compile the project, update the scene, enter play mode, and show whether the result actually works. Leeway connects those two sides. It is a bridge between coding agents such as Codex, Claude Code, or Cursor, and the Unity editor. The coding agent understands the request, plans the implementation, and decides what should happen next. Leeway gives it a controlled way to perform those operations inside Unity and receive the results. The workflow begins by starting the bridge from the Leeway window. When the coding agent needs something from Unity, it sends a request through Leeway. The request is performed inside the active project, and the result is returned to the agent in a clear, structured form. This allows the agent to inspect scenes, hierarchies, assets, prefabs, settings, and diagnostics. It can create or change project content, control play mode, and validate the result without relying only on the files it has written. The agent can also request screenshots of the game view or other parts of the editor. This gives it visual feedback, which is important because successful compilation does not always mean the scene looks or behaves correctly. The process becomes a continuous loop. The agent makes a change. Unity checks it, Leeway returns the result. Then the agent uses that information to decide what to do next. Leeway is also designed to use fewer tokens. Instead of giving the coding agent a large collection of general-purpose MCP tools, Leeway provides focused Unity operations and only returns the project information needed for the current task. This reduces unnecessary tool calls and leaves more of the agent's context available for understanding and improving the project. Because Leeway works with coding tools you may already use, you can keep using your existing Codex, Claude Code, or similar subscription. These subscriptions usually provide more usage than many third-party tools. This means you can run longer Unity tasks and complete more work using a subscription you already have. You do not need to pay for another AI service or purchase separate API credits just to connect an agent to Unity. To test the complete workflow, I wanted a task that involved more than creating one script or changing a single object. The idea is a football pool game. It is a pool-style game played with footballs, using an aiming system inspired by FC26 shooting controls. The player should be able to choose where the ball is struck, control the power, and add curve or height. The project also needs an arena, cameras, gameplay logic, menus, interface elements, and an organized Unity structure. I prepared one detailed prompt describing those requirements and included reference images for the controls and visual direction. For this demonstration, I am using Codex as the coding agent. Once the request is ready, I submit it as a longer-running task and allow the agent to begin working. The agent begins by inspecting the project and planning the implementation. It then creates the folders, runtime scripts, materials, meshes, prefabs, and supporting assets needed for the prototype. Unity imports those changes and reports its current state through Leeway. The agent builds the arena, prepares the scene hierarchy, adds required components, scripts, references, and begins implementing the gameplay systems. When Unity reports a compiler or editor problem, the agent receives that diagnostic information. It returns to the relevant part of the implementation, makes a targeted correction, and waits for Unity to compile again. This cycle continues throughout the task: implementation, Unity feedback, correction, and validation. Once the initial implementation compiles, the agent enters play mode and checks the first playable version. The foundation is working. The arena exists, the footballs are inside the scene, and the first gameplay systems are beginning to function. However, there are still visible problems. The balls are not arranged correctly, the presentation is rough, and the complete animated interface requested in the original brief is missing. This first play mode test shows why visual validation matters. It reveals problems that would not be visible from the scripts or compiler output alone. After reviewing the first version, I give the agent direct feedback about the ball arrangement and the missing interface. The agent keeps the existing project context and continues from the current implementation. It corrects the ball placement, improves the presentation, and creates the football menu and interface. Throughout the revision, both sides of the workflow remain visible, Unity changing on one side and the coding agent reading results and making decisions on the other. The project is launched again, the updated scene is inspected, and the remaining issues are addressed. After the revision, everything remains inside a normal Unity project. The scripts, materials, meshes, prefabs, audio menus, scene objects, and folder hierarchy are all available as editable assets. A developer can inspect the scripts, change the materials, move objects in the hierarchy, replace parts of the interface, or give the coding agent another request. Leeway allows the agent to work inside the existing Unity workflow, while the developer keeps full control of the project. Now we can look at the completed result. The game opens through the football menu and loads into the finished arena. The player can aim the shot, control its power, add curve and height, and adjust the camera while playing inside Unity. The first attempt was not perfect, but the complete process is what matters. A detailed brief became an editable Unity project. The coding agent created the first version, Unity exposed the remaining problems, visual feedback guided the revision, and the improved result was tested again. Leeway connects that entire workflow from the first request to the final playable result, while keeping it controlled, visible, and token efficient.